Hi everyone, welcome back to Code for Teachers. I'm Michael Taggart, and this is Chapter 5, the Palindrome Detector. I know it's been a while, and that's because I wanted to make sure I had the time to put together this full lesson for you. So here it is. I hope you enjoy it. The first thing we're going to be doing is we're going to be learning what palindromes are. It's a fairly common term, but in case we don't know, and in case our students don't know, we're going to review what they are. We're going to create a command line tool that helps us detect palindromes. We're going to handle user input, and then we might add some extra functionality to make the palindrome detector even more fun to use. There's a bonus at the end, too, about an alternative program structure, but we'll cross that bridge when we come to it. So, this is really not just about writing the code, this is about lesson design, and that's how we're going to take these videos moving forward, is really the full design of the lesson, not just code concepts. So the first thing to do is to discuss palindromes with your students, and this is always a lot of fun. Palindromes are series of numbers or letters, or combinations thereof, that are the same forwards as they are backwards. So, race car, so many dynamos. These are some examples. And so the first thing you want to do with your students, and this doesn't need any technology, is just make up some palindromes, get them on the board, have them work together to come up with some. They could be nonsense, they could be combinations of words, they could be numerical, as long as they definitely grasp the concept of a palindrome. And then you want students to write out the procedure in English of how to detect the palindromes by hand or manually, right? So you want to say, okay, the first thing I need to do is look at the beginning of the word and then at the end of the word, and if they match, then I need to keep going. Figure that out, write it down step by step. And then once you have that procedure written out, you want to identify the pieces of the procedure that can easily be translated into Python. And only then are you ready to code. It's important, to me at least, that as we're teaching students to program, this process of identifying procedure without code happens first. It's a very bad idea to just jump in and start writing code without a plan. More often than not, you're going to end up with a messy program that you're going to have to refactor later anyway. Once you have the understanding of structures of code, you can do the pre-planning before you get into your editor and start writing. So, just some examples of palindromes that I particularly like. When we ignore spaces and capitals, race car, so many dynamos, 1001, taco cat. These are great. There are lots of others. I hope that you have a great time with your students coming up with palindromes to test. So let's think about how we do this human style, right? Not a computer's methodology, but a human's methodology. Let's take race car. The first thing we're going to do is we're going to strip out all the spaces and capitals, so we just have this group of characters. And how do we know that it's a palindrome? Well, we're going to look at the start and we're going to look at the end. If at any point during this splitting off, the letters don't match, we know we don't have a palindrome. But R is the beginning and the end of race car, so we're going to keep going. We take the next two off and we examine them. Do they match? Yes, they do. We keep going. They match, leaving us with a single character, which, by the way, is the simplest palindrome possible. And that's going to come up a little bit later. So a single character is a palindrome based on this logic. And since we've arrived at that, we know for sure that we have ourselves a palindrome. And again, don't forget that if at any point the ends don't match, the test fails and we don't have to check the rest of the word. That's going to be important in our program. All right, so let's think about the function design. We want to write a function that is called isPal or is_pal if I'm writing this correctly for Python and not for JavaScript. And it returns a bool. And so it takes a string, test, and it's going to return true or false. Now, there are two approaches to writing this function, iterative and recursive. Iterative uses a loop, an iteration. Recursion calls the function on itself. That's going to be the bonus section. We will write both the iterative and recursive versions of this function. But for now, we're going to focus on iterative. A couple of reasons. One, we haven't really talked about recursion yet. And two, it'll be a lot easier for our students to begin with an iterative approach rather than a recursive approach. So let's think about the iterative approach. What we're going to do is for the length of the string, starting at I equals 0, we're going to loop. And we want to check the index I in that string against the I in the reverse of the string. If they match, we're going to keep going into the string and checking that index against its reverse. If at any point they don't match, we're going to return false right away. The loop ends, the function ends, it returns false. Otherwise, we're going to just do nothing and keep looping. But if we get to the end of the loop, that means that we got through the whole thing testing against the reverse and never found a mismatch. What that means is that we're going to return true. That's a palindrome. Now, let's think about an application versus a program. You can run code as we've run in Replit, and it works just fine even if you mess with some of the source. But an application is highly usable by non-programmers. We shouldn't have to change variables every time we want to test a different string. And actually, we shouldn't have to open the code at all. And you know that because you don't have to open the source code for the applications you use on a daily basis. You're not editing the source of your web browser or of your word processor or anything like that. Programmers write user interfaces for their code so others can use it. Most UIs, user interfaces, are graphical these days. We call them GUIs or GUIs. But before GUIs, there were command line interfaces or CLIs. And I admit I have a love affair with the command line. It is my favorite part of computing. But it is also a great way to get started with students writing full applications, not programs. Writing graphical programs can be a bit daunting at first. Unfortunately, especially in Python. So writing command line tools, a lot easier. Now the other thing that we're going to use this time is a proper text editor. We're going to be running this program actually on our computer. And so here are 3 recommendations for text editors. On the left you have GitHub's own Atom text editor, which I've used for a long time and think it's fantastic. Sublime Text, a lot of people swear by it. I don't use it myself. And Visual Studio Code, which is from Microsoft. I use Visual Studio Code these days, and this lesson is going to use Visual Studio Code. It's very similar to Atom, very similar to Sublime Text. I just happen to like the way that VS Code implements certain features. Make sure that your students and you have one of these if you're going to write a lot of Python on your computer and run it on your computer. Let's also talk about the command line and what that looks like, what that means. So it's a text-based interface to run programs and navigate files and folders. If you grew up in the era of DOS, Windows 3.195, you know exactly what this is. This is the command prompt with C:\\, right? Or on Mac OS or Linux, that's the terminal. Now, different operating systems use different command line interfaces. Like I said, Windows uses a command line that's based on DOS, so it's a little bit different, whereas, or cmd.exe is what it's called these days. But on Mac OS or Linux, it's called terminal, and the command line is based on the old Unix shell. And we are going to use a Unix-like terminal for our purposes. A couple of reasons for that. Number one, I use a Linux computer in my day-to-day life, so it's a Unix-like terminal, but also because a Unix-like terminal is more powerful as a command line, and it's so powerful that Windows has taken steps to bring Unix-like interfaces over to Windows these days. So if you're on a Mac, make sure that you have terminal open. And if you're on Windows, you can use Cygwin or MOBA Xterm if you want to get the same experience. The other option that you're going to have, especially if you're on Mac or Linux, is that in Visual Studio Code, there's a built-in terminal, and that's exactly what we're going to look at right now. All right, so here's Visual Studio Code. This is our programming interface, and let's get familiar with what's going on here. My main view is my source code. I've done some boilerplate here, and I have a couple of words up here like import sys that we'll be talking about in a second. Let's not worry about the code itself right now, just the interface. So I have these 5 icons over here. This is my file directory. You can see that I have my Code for Teachers folder open, and it has some subfolders with different code inside of it. And I can navigate through all of these and see what's going on. And this actually is the local version of the GitHub repository where all this code is stored when we're done and you're ready to look it over. I have a find and replace. Right. I have a debugger. This is source control. This is Git. We'll talk about that in a much later video. And extensions, where you can actually install extensions for Visual Studio Code to change its functionality. I'm going to close this up for right now. Okay, and on the bottom right, it shows me that I'm working in Python, and that's how the .py is how Visual Studio Code knows to highlight the correct words. It knows the keywords import, def, and return. All right, so the other thing I wanted to show you about Visual Studio Code is the built-in terminal. Before we had tools like this, we'd have to have multiple windows open, one of which was a terminal, one of which was our text editor. There are text editors that work in terminals, so maybe we were using one of those. But for Visual Studio Code, I can use View and Integrated Terminal, and it'll actually open up my terminal right here. And you can say it says bash. That means the born-again shell. That's the default shell for Linux and Mac. So let's get comfortable with a couple of commands here. So the first is the ls command. What you're looking at here is just kind of where I am in my computer. And if I ever want to, I said ls, but actually we're going to learn one before that. If I want to know exactly where I am on my computer, I can type pwd and press enter, and that'll tell me the entire path to my current location. So all the way from the top of my hard drive down into the home folder, my user, documents, projects, the forever student, code for teachers, and then this is the code for teachers repository. And if I want to see what's inside of the folder I'm currently in, I can type ls, or list short, and it'll tell me that I've got 5 folders and the license and readme file. And I know I'm in chapter 5, I should be in that folder. How do I get to that folder? CD, or change directory, will take me down into that folder. Think of commands on the terminal like verbs. They need objects, or functions that require arguments. So if I say CD, I need to tell it a place to go. And if I type ch5 and press enter, you'll notice that my prompt changed. And now, if I type pwd, now I'm inside of chapter 5. And let's ls, see what's going on in here. Is pal.py, that's my Python file. That's the file I'm editing right now. Let's take a look at what we have going on here inside the code, now that we have some familiarity with our terminal. The first thing I do is import sys. Also notice that when I highlight over it, I get documentation directly from Python in Visual Studio Code. One of my favorite features. Okay, so it tells us this module provides access to some objects used or maintained by the interpreter. Basically what it means is that we get access to system properties. And the one we're actually going to use is argv, command line arguments. So when we run this program from the command line, the stuff we pass into it from the command line is going to live in this list called argv. You'll notice that it says argv0 is the script path name. So So let's test that out. If you look down here underneath my function definition, which I'm going to close for just a moment, I have a variable called string to test, and I've set it equal to sys.argv1. And I'm going to then print the string to test just to show you how this works. So how do I run this program from the command line? So I'm down in my terminal, and I'm going to type Python, and then I'm going to give Python something to run. So don't press enter yet. I type Python, and then ispal.py, and then I'll give it a command line argument, like hello. And if I press enter, check it out, it printed hello. If I try to run it without a command line argument, I get this error, and this is a Python error that says that the list index is out of range. What list? sys.argv. And the index 1 was out of range because we didn't give it anything in the second slot for sys.argv. So there are some safety things you can do to make sure that that doesn't error out and you have some graceful failure. But make sure that when you're running this program, you actually give it something to test, like race car. Now, we're not doing anything yet. We're just printing it out. So let's actually write our function. Let's implement ispal so that it does some work. Let's think about, I'm going to close the terminal just so we have the full use of the screen here. All right, so the first thing we need to do is reverse the test string so that we have something to look at easily in the reverse. So I'll call that reverse test. And if you remember back when we were looking at lists and indexing and slicing, we have a pretty quick way of reversing strings, which is to take test and index it this way, all the way through with no skips, and we're going to have an interval of -1, which means that we walk backwards through the test and make a reversed copy of it. Now we're going to loop through the test test against reverse. What that means is we need to loop not through the characters but from the indices of those characters. So if we were to loop through the characters of test, I could say for I in test, and that would give every character like RACECAR. But I actually want the integer, I want the index so I can use it on both reverse test and test. So I'm going to change this up for I in range, just like we did before with numbers. But what's my range? Well, it's however many integers starting at 0, the list of integers long enough that it covers the entire length of test. So I actually have the built-in len function, and I'm going to say len test. So let's just take a moment here. So len test is going to return the length as an integer of how long my test is. And then I'm going to use that in range to give me indexes 0 through the length of my string -1. So that's going to give me every index in my string. So then I have to test the character that I'm looking at against the same address in its reverse. So I can say if test index I is not equal, because we want to test to see if it's not equal really, or bang equal, right? Test, I'm sorry, reverse test I, give us a colon, we will return false. Oh, by the way, there's another way to write this. They're logically equivalent. It's just, your style. So this is using the bang equals, the not equal operator. But if I wanted to not use that for whatever reason, I could actually use the double equal sign and then just negate it this way. Say if not test I equals reverse test. Those two expressions are exactly the same. I like using this one though. Return false. Now that's all I need to do inside the loop. If I get to the end of the loop and I haven't hit the return false, then I've returned true. All right, cool. So let's write some code out here on the outside. We're outside of the function now. Our function is now perfectly implemented. Well, not perfectly. We have some errors here, or some non-robustness. So we have string to test saved in a variable. Now let's do something with it. So we want different output for our program depending on whether or not it is in fact a palindrome. So if I could say if is pal test, right? Print, you found a palindrome. Or if I really want to be fancy with it, I can say string to test is a palindrome. Else print string to test is not a palindrome. Okay, so here is our entire code. Let's give it a test run, shall we? So I'm going to bring back my integrated terminal. Bring it up a little bit. Clear up the screen so we can just see it. Okay, so I'm going to run Python is pal, and let's give it taco cat. I made a mistake. Let's find out where I made a mistake. This is going to happen, and it's actually worthwhile that it happens. So it said line 27. If is pal, that was dumb. Okay, so if I say I used the wrong variable name, what I really meant is if is pal string to test. Test is only inside of my function is pal. All right. So it's going to be important for you to learn how these errors are printed, are written, so that you can read them and find the error not only in your code, but to help your students find the errors too. It's also a good habit for students to get into to look for line numbers to see exactly where the error is that Python found. All right, let's try running that again. Taco cat is a palindrome. That's what I got back. Let's change it to taco car. Taco car is not a palindrome, and I forgot to put a space before the word is in that condition. Let's fix that. Hey, that looks better. Okay, taco car is not a palindrome. We now have a working command line tool. Let's think for a moment about some of the ways in which we could make this program more robust. Well, let's see. You could imagine that if I gave it something like race car, first of all, because there's a space here, it's not really going to know what to do with it because it's going to think race is the command line argument at that index and then car is another one. So if I press enter, it's going to say something like race is not a palindrome. Exactly. It ignores car entirely. If I put this inside of quotes, let's see what happens. Ah, see, this time it gave it all to me and it took care of the space. What I'd love to do is clean up the input, right? So basically I want to give a normalized version of the string to my function, or have my function normalize the string, meaning turn it to lowercase and get rid of all spaces, things like that. So luckily, we have some really easy ways of doing that. All I need to do is modify this line right here. Python has some very strong string operations, so we can use the replace. And again, let's just check out this documentation. So good. return a copy of s with all occurrences of the substring replaced by new. And we could do it for a certain number, but by default it's going to do all of them. So I can say replace. So old is going to be space, and we're going to replace it with nothing. Let's save that and run that code. Python is pal, and let's use race car. So it took that space right out of there, but I still need to get rid of those capitals. I can chain functions in Python, and I'm going to. So after this replace, I'm going to say, okay, well, we've replaced the spaces, but we need to get this all to lowercase. What do I have? Lower. And that's going to do it for me. So let's see if I can run this now. Race car is a palindrome. Look at that. So it took out the capitals and the spaces for me. That's a nice, robust sanitization of any input, any sane input that I would get. All right, now let's talk about recursion. Instead of a loop, instead of that for loop, a recursive function calls itself with varying arguments. So if our function was called isPal, inside of the function we would be calling isPal with some modification of the original arguments. The trick is that if you do that wrong, you're going to be looping, you're going to be recursing forever. So when the function finds a base case, that's when it returns something. So we have to be a little clever with recursion about deciding what our bases are. A base case is the smallest possible reduction of the information the function is working on. Why would we use recursion at all? Well, it's efficient for certain cases. It's computationally efficient. But also, it's really cool to teach students about recursion because it demonstrates the following. So much of programming is about taking a big problem and breaking it down into smaller, easy-to-solve problems. That's what recursion does. Finding that base case and working toward that base case is the essence of recursion. So let's think about recursive function design here. We need to identify our base cases for palindromes. What are the simplest possible palindromes? We mentioned it earlier in the video. Here it is. A single character string is always a palindrome, so that's going to work out just fine. And there's a minor modification of that. There are kind of two base cases for palindromes. A two-character string is a palindrome when the first character equals the second character. So we need to have kind of two base cases. If we get a single character string, then we're good to go. And if we have two characters remaining, then we want to look at the beginning and the end of that. Anything larger than that, then we're going to try to split and then recurse again. So we check the arguments against the base cases. We check the test coming in. So if it's a single character string, we're going to return true, and if it's a two-character string, we're going to return whether S0 equals S1 or test0 equals test1. If they aren't base cases, then we actually have to do the check of the first character against the last. So it would be like S0 equals S-1, right? Because we're looking at the very end, the backside of the string. We don't have to use a reverse test variable in the recursive version because we're only ever looking at one string. Now, if they match, we're going to chop off the ends and send the interior characters back around into isPal, and we're going to keep checking and chopping until we get down to those based cases. Otherwise, we're going to return false, right? If they don't match, then we don't have to go any further. So let's give this a shot here. So we give isPal to race car, right? We give it to the recursive version of it. So the first and last match, but it's not a base case because we have all those extra letters. So that means we're going to chop the R's off, and we're going to give isPal again the interior of race car, ace car, if you want. Let's do that. Let's see what that's about. So the first and last match, but it's not a base case. So again, we send the CEC back into the isPal function. Now the first and last match, but it's not a base case, so we chop the C's off. We're going to send isPal oh, I'm sorry, that should say E, right? Not ASCA, right? So we're going to say E, we're going to send that around, and E is in fact a base case. So return true. Let's write this thing and see what that actually looks like in practice. Okay, so we're going to write this from whole cloth here, no boilerplate written at all. So I'm going to write a brand new function. Down here called isPal recur to tell us that it's recursive test. We'll use the same argument name. Okay, so first thing we need is to check base cases. How do we check the base cases? Well, if len test equals 1, return true, right? Because a single character is always a palindrome. Cool. Let's say elif len test equals 2, return test 0 equals test 1. So what we're saying is, if it's length of 2, return the Boolean value resulting from this test, testing the first character against the second. All right, else. And inside this else, we're going to have another if. And say if test 0 equals test 1. Sorry, test negative 1. So the first equals the last. Then we're going to call isPal again. isPal recur again. But we're going to give it test 1 to negative 1. If that's not the case, we could say else return false, but we don't actually need the else. Just say return false. Now, this is a complete if-elif tree. And if you want to write it this way, that's totally fine, and it's going to make a lot of sense to your students to write it this way. I do not employ this structure myself. I want to separate the base cases into 2 separate conditionals. We're going to do that test if they fail anyway. So you can write it this way, but I would like to write it in a way that avoids the else. So to do that, what I would do is this. Oh, one last piece. We actually need to return this. All right, why is that cleaner? Well, we have 3 possible things, right? 2 base cases and then the rest. We've got returns everywhere, so it's very clear to a programmer looking at this that there's no way this thing can completely fail, right? There's no way that the function doesn't return something. Now, to actually employ this isPal recur, then we are going to change this test here to isPal recur. Okay, let's save that and let's run it. Okay, something went wrong. Let's see what it is. How do we see what it is? Easiest way, print test. Too many colons. There we go. So again, good debugging. That was just a typo on my part. So it should be test colon -1, not 2 colons, because we're going from the first index to the last index. We're not using a special interval. So, but it's kind of cool to see once we have this print in here, because when we run it from the command line, it shows us exactly how the recursion works. And race car is, in fact, a palindrome. We can comment that out if we want. We don't need that in there. You can give that whatever you want, right? Rise to boat, sir. Or so many dynamos. There you go. So now we have the recursive version as well as the iterative version working of this program. All right, that is the program, but not the lesson, right? There's a lot to unpack here for our young programmers. Whether it's about the nature of palindromes, it's about the nature of recursion, it's about building command line tools, if it's about using command line, or even about the process of debugging. Students are going to make mistakes. You're going to make mistakes. It's okay to make mistakes together, because a lot of the process and art of programming is figuring out where mistakes are and how to fix them and how to do things better. You know, programming is never quite finished, right? Even the best program probably has some room for improvement. We can always optimize. We can always clean up. And so learning to be patient with ourselves and take the time to find the mistakes and to fix them, even when it's frustrating, is really important as a soft skill for programming. So I hope you and your students enjoy this exercise. I hope you write some cool Python. If you want to read a little bit more about EdTech, you can go ahead and check it out at theforeverstudent.com, or hit me up on Twitter at mttaggart or on GitHub at mttaggart, where this code will reside. I'm Michael Taggart. Thanks for watching.